All right, here we go again. This is the final slide from the logarithms set, okay? Infectious disease outbreak. Suppose the beginning with 5 infected individuals, an epidemic breaks out with each infected individual infecting 2 healthy individuals each week. The number of infected individuals after T days may be modeled as I equals 5 times 3 to the power T over 7. Predict when the 100th person will be infected. Okay? Okay, so first things first. Okay, now the question is, can you now see what I'm doing here? Can you see that? Can everyone see that? Okay, if you can't, complain. Okay. Where do the bits of this thing come from? This 5 is just the initial number, yeah? This 3, where does that come from? That's 1 plus 2. 2 is the number of healthy individuals infected by each infected person each week, okay? So if you've seen that, the expression for compound interest, it'll look like 1 plus I to the power something, right? 1 plus I. The interest here is the number of people you infect, okay? Or if you want to think about that sort of bacteria doubling thing, right? Each bacterium gives rise to another, right? And so the number doubles. So it's 1 plus the one that it makes, okay? So it's 1 plus the number you infect. Does that make some sense? Okay, if it doesn't make sense, complain, okay? But anyway, that's where that 3 comes from there, okay? It's you plus the 2 people you infect. Okay? 7 is because you infect 2 new people each week, okay? So you've got to divide this, which we said was in days, just to confuse everyone, right? So T days. So you've got to divide by 7 to get this thing in weeks. Does that make some sense? Okay, if it doesn't make sense, plug in 0 here, and you'll get 5, which makes sense. Plug in 1 here, and you'll get 5, oh sorry, not 1, 7. Plug in 7 here for 7 days, so after a week. And you'll get 5 times 3, okay, which makes sense as well, okay? So it's 5 people plus the 10 people they've infected, okay? Yeah. Yeah.
Can you go over how you got 1 plus 2?
Sort of, okay. Okay, so just think about the first week. Okay, during the first week, what happened? So you had those 5 people who were infected at the beginning, okay? And then each of them infected 2 more people, okay? So that's plus 5 times 2. Okay, and you can factor out and you get 1 plus 2. So it's 5 times 3. And if you just repeat that a few times, you'll see that it works for any number of weeks. Fair enough? Okay. And again, if you've seen interest calculations, that's what they look like. They look like 1 plus I, right? Okay. All right, that's that. 1 plus 2 is 3. Okay, and we need to find out when the 100th person is infected. So we need to solve for IT equals 100. Okay, and if you want, you can call it T star or something. Okay, so we just plug in and solve. 100 equals 5 times 3t over 7. Okay. Divide both sides by 5 to get 20 equals 3 to the t over 7. Okay, what do we do now? Log it. Yes, log it would be good. Okay, good. And do I do just go that way? Yeah. Okay, so what log? Do you care what log? What base? 10 or e or anything. Yep. Good. Just not 1 or something negative or 0. I'll say ln just to annoy you. Okay? And then what happens? Okay, t over 7 comes down. Am I below the level of the thing now? Okay. Does that make sense? Okay, so whenever you want to solve something like this, you take the log on both sides, the exponent plops down like that, and then you can just solve for t. So t over 7 is equal to ln 20 over ln 3, or t is equal to 7 ln 20 over ln 3. Okay? And that's about, unless I calculated it wrong, 19.09 days. So you say they've been infected around the 19th day or something like that. Okay? Okay. Another way to have done this would be to say that t over 7 must be, let's go over here. T over 7 must be the log base 3 of 20. Right? You could have said t over 7 has to be the log base 3 of 20. Okay? And we talked about change of base, right? So you can, we talked about change of base, so you could write this as this. And lo and behold, it's the same thing. Okay? And yes, I did do log to upset you. You could have used log base 10, log base 2.4, whatever you want. Okay? Okay, questions? Brilliant. Yes, sir.
Would we need to simplify to this form, or would we have to actually give you a number, or like a midterm or something?
See, it's math, right? In math, I tend to give answers like that. I mean, if it says after how many days... Oh, boy. Let's say we'll tell you. How's that? Is that a good answer?
Yeah.
Exact unless told otherwise. That's what you assume in math, yes.
So by default, that equation over there, it's essentially like the base times 1 plus interest,
Yeah.
and then t over like the half-life or like
T over
their life.
how long it takes for this multiplier to take effect.
Yeah.
And it takes effect every week, so every 7 days, and that's why that happens. Okay? All right, good? Yeah, half-life would have made sense if it was a half in the base of the, yeah. Okay, good. All right. If you have questions, shout. If you have any questions about that domain thing from today, tell me that as well. Okay, I'm going to quickly address one thing that comes up. This came up in that range and domain thing from last time that I wrote that essay about. Okay, so again, if you have something like this, solve, and you may never even see this, okay? But if you get given something like this, okay? Someone asked me when to flip the inequality direction, okay? And one time you flip it is when you multiply or divide by a negative, okay? A more general case is something like this. Okay, so 9 is just 1/3 to the minus 2, okay? But because this thing is a decreasing function, okay, you don't just go ahead and write that, okay? That's not it. You've got to flip it. That's it. And that makes sense if you look at the picture. So that's roughly what that looks like. Okay, that's what this thing looks like. Okay, and we say it has to be less than or equal to 9, so let's say 9 is over here. That's ridiculous scaling I've got. Let's say 9 is over here. If you want to be less than or equal to 9, then you've got to be here. And that's greater than or equal to minus 2. Okay? Not less than or equal to minus 2. Okay, if you look at the picture, it all makes sense, right? That's it. That whole inequality flip thing, that's all it is. Okay? Yes? At the back.
So you know when you were solving for IT100, so when you were reducing the 100, did you reduce the 5?
Yeah, I just divided both sides by 5. That's it. Okay? Okay. All right, you get to vote on what I do now. Okay. Someone wanted inequalities and absolute values and stuff. If you all want that, I'm happy to do that, okay? Look, who wants that? Actually, no, I'll tell you what I'm going to do first. Withdraw that election. I'll do it later, so we do some important things first. Okay. Okay, here we go. Problem, in case you were wondering. F at x is equal to the square root of 1x minus 1. G at x is equal to... Some of these may look familiar. E to the 1 over x plus 1. And C is h at x equals e to the x. All right, what I'm going to do is I'm going to find the domain, the range, the inverse, and its domain and range. Okay? Okay, now get out your eye clickers. All right, which one do you want me to do? Who wants A? Who wants B? Man, who wants C? That's amazing, guys. We got 2, 0, and 1 votes, I think. So, oh, 2 is all right. Okay. All right, I'll do the first one first, and, and then the third one second, possibly. All right. So again, I'm going to find the domain, range, inverse, this kind of stuff. That's good. It's never this early. Okay. All right, let's find the domain of this thing. Okay, what can't happen? All right. Ln has to take something positive, yeah? So that better be positive. So x minus 1 better be positive. Okay, or x has to be greater than 1. Good? Yes, ma'am?
Sorry, this is going back to the graph you drew over there.
Yes, ma'am.
Could you please explain?
Yes, what I said here?
Yeah.
Yeah, okay, so I said, if you want to solve this, okay? At minus 2, this graph is at 9. Does that make sense? Can you?
Yeah.
This is okay. All right, and we said we want to find where the curve is less than or equal to 9. So you want to find where the curve is below 9 or at 9. Right? So I sort of scribbled the bits of the curve that are below 9 or at 9, and I found which x values corresponded to that. Does that make sense? And it's just minus 2 onward, which is what that says.
Okay.
That's it. Okay? Thank you. Okay. All right. Okay, so that's the first thing. Ln can only take positive arguments, so that's what that says. Also, square root can only take non-negative arguments. So ln x minus 1 greater than or equal to 0. No? Okay. Okay? How do you get this? Or in other words, okay, ln looks like this. Yeah? Thing, ln of thing. Okay, so for the ln to be greater than or equal to 0, the argument has to be greater than or equal to 1. Cool? Does that make sense? Okay. You know, and this honestly pretty much gets built into this, okay? But it's okay to be redundant. And if you wanted, yes? Did I make a mistake already? Yeah, go ahead. You, sir.
Would it make logical sense to say like e to the 0 has to be greater than e to the 0, which would be 1?
E to the 0?
Yes.
To say this? Has to be greater than or equal to 1? No, it has to be greater than or equal to what?
Yeah.
E to the 0 has to be greater than or equal to x minus 1.
Oh, okay. Greater than or equal to or less than or equal to? Less than or equal to, I buy. Yeah, so you go e to the this, e to the this, is that what you're saying?
E to the 0 will be 1, so you get the 1 on that side, and you have x minus 1.
Yeah, that works, yeah. So you go e to the this, e to the this, right?
Yeah, so I don't have to draw a graph.
Right, yeah. Yeah, that's fine. In my head, I see this, and it also keeps me from being confused about this kind of thing. Is that fair or no? I'm okay with this. What you said is fine. Yes. Okay, yes. Like you said, you can raise e to the 0 and e to the this. You get the cancellation here, and e to the 0 is 1, so that works. Yep? Okay. Yeah, and again, that's kosher because e is increasing. Okay. Okay? Okay, x greater than 1, which is kind of stupid to even mention, x greater than 1 and x greater than or equal to 2 just means x greater than or equal to 2. Okay? So the domain is this. Okay? Okay, so what's the range of the inverse function? And there's only one reason I would be asking this now. It's the same. Okay, and I'm going to keep calling the range e. Okay, so the range of the inverse function is the same as the domain of the function, so there you go. Okay? Good? All right. Now, I'll tell you how I think about range, and then you can think about it however you want. Okay. What I did to think about range was I think about where this thing maps through that function. Okay, where this maps to through that function. Okay, but there's a bunch of ways to do it. So for instance, I want to see where this interval winds up. Okay? Okay, so that's the interval of x. Okay? So x minus 1 then, okay, so if I subtract 1 from everything, okay, the things in that interval get shifted, and this interval maps to this interval. Okay, if this doesn't make sense, I'll say it a few different ways. Okay? So, x minus 1 then winds up on this interval. Ln, okay, so if I take the ln of these kinds of things, okay, what happens if I take the ln of something that's 1 or greater? I get 0 or greater. What happens when I take the square root of something that's 0 or greater? I get something that's 0 or greater. And that's it, we're done. Okay? And that's the range of the function, or the domain of the inverse. Did anyone appreciate that?
I don't know.
It's okay. It makes sense to somebody, then I'm happy. Okay. All right. Again, what am I thinking? I'm thinking, okay, if the input has to be in this interval, okay, so if the input's in this interval, okay, then input minus 1 is going to be in this interval. Ln of something in this interval is going to be in this interval. You could look at the graph or just take ln. And the square root of something in this interval is in this interval. Okay, so that's how I thought about it. Okay, another thing you could do is sketch graphs of each step, or you could sketch a graph of ln x minus 1. Okay, and see where the domain maps to. Or, okay. You can think about ln x minus 1, and what's its range? What is the range of ln x minus 1? What's the range of ln x? Everything, yeah? Good. And ln x minus 1 is just transformed a bit, that's everything as well. Okay? So the range of this thing is everything. Okay. When you feed that into this thing, okay, the square root gets upset if you give it anything negative. But as you give it all the non-negative reals, it spits out all the non-negative reals. Okay? So when you have a square root function, okay, again, the stuff you're putting in, okay, it will accept anything non-negative, and over that interval, it'll return everything non-negative. Okay? And that, again, tells you that the range of f is just a non-negative. Does that make any sense? Who's upset and confused? Okay. Is that myself, not you? Okay. Does it make sense that ln x minus 1's range is r? Does that make some sense? Okay? Because look at the graph, it goes everywhere vertically. Okay? Now, the only other thing you're doing is feeding into the square root. Okay? The square root gets upset if you give it anything negative. Okay? It'll accept anything non-negative. Okay? So it'll accept the non-negative part of this. It'll accept all the non-negative reals. Okay? And as you look at all the non-negative reals in the square root function, you get out all the non-negative reals. Okay? So the input is something in the non-negative reals, your outputs are in the non-negative reals. And that's why the range of the whole thing is the non-negative reals. And that's it. Okay? Again, draw pictures if you want, go step by step if you want, whatever you want. Okay? All right, ask me questions, specific questions, and I'll try to answer them. Okay? Let me write the expression for this thing now. Okay, and if someone said find the inverse, in an arbitrary place on the board. Okay, y equals f at x. Okay, and then solve for x. Okay. Okay, square both sides. And at that point, I'm already getting nervous. Okay, e to the both sides. Add 1 to both sides. So f inverse, and I'll put y in here, but you can put x. So f inverse is e to the y squared plus 1. Okay? Now let me get something right here. It's having a fit over here. Okay, there we go. All right? This bit here is our main function. And that guy up there is that thing. Okay? And as you can see, this squaring screwed us over a bit. Okay? It gave us something that's not quite the inverse of this thing. Yeah? So what saves us? We have to say explicitly what? Exactly. Okay, and in fact, I'm going to change all these y's to x's to make things nice. Yeah? Okay, so I say what the domain was. We found the domain, you've got to indicate that fact, okay? Because as soon as I did this, I introduced a problem, okay? This guy has to be non-negative. Okay, so I've got to keep that throughout, and that's what causes this to happen. Does that make some sense? Anyone upset?
Why did you change the y to the x?
Because on that graph, x is there, y is there, and to graph this, how do I put this? To graph the inverse, you have to treat x as the input. Either way, I don't care what you do. It's fine either way, yeah? But to graph it, and you want to treat this as x, then you want to do this. Okay?
But in order to find the inverse, you kind of just switch the variables that never change from.
You see, I don't care if you switch them or not. Because if you put, a z in here and a z there and a z there, that's still the same function. It doesn't change anything. Right? It's just that to keep in your head that x is input, or to keep in your head that x is horizontal, then it makes sense to change everything to x's. Okay? Not okay, huh? You're lying to me. Okay, who's upset? I like that better, because when I get no hands, it means I'm perfect. Okay. Okay. What exciting colors we have. Okay, is anyone upset about this XY thing? Yes, ma'am.
Is the other problem for like the B and the C as well?
Yeah. You want them?
Yes.
Yes. Oh, you said B and C.
Oh.
I hope you were part of our election turnout, otherwise I'm disappointed. Okay. All right. Here we go. B? No, C. Haha, okay, good? Okay, here we go again. Domain. Domain of H. What do y'all think it is? Haha, y'all. What's that? Everything? Yeah, that's cool. Good, everything, good. Okay, so the domain is just all the real numbers. And that's also the, I'll just keep doing that, okay. The range of the inverse. Okay, y, I can put anything upstairs in an exponential, and similarly this guy doesn't care what you give it either, okay? So you can put whatever you want in there, okay? All right. Good. The range. Okay. What?
They're all positive.
Uh-huh. All, yeah, something is, yeah. Okay, so I'm going to do this in the language I did the last one that you all loved so much. Okay, so if I put real numbers in here, okay, so if I put a number in here, e to the x is what? It's always positive, yeah? No matter what I put in, e to the x is positive. And the range of e to the x is all the positives. So when I do that the first time, I get the positives, okay? Right? Everything's positive. Good? Okay. Bad place to draw that. I refuse to calm down. Okay, good? All right, so that's the first one. If I exponentiate again, okay, now if I exponentiate again, okay, what am I doing? What's that? Okay, 0 onward maps to 1 upward. Yeah? That's it. Okay? So if I put anything in an exponential, I'll get the positives. Okay? If I put anything positive in an exponential, I get everything greater than 1, which is what that says. Does that make sense? Repeat?
I'm just trying to work this out in my head.
Okay. Should I be part of that?
Okay, I don't get how like at one point it's like 0 onward and now suddenly it's 1.
Okay, so here's the thing. I took the exponential once and then I did it again. That's what this is, right? This is exponentiating and then again. Okay? So when I put anything into this, okay, e to the x is going to be here. Okay, so here's step 1. Okay, I give it anything and it gives me anything positive. Okay? Step 2, I give it anything positive, it spits out 1 and greater.
Okay.
That's it.
Okay, I
So
get
you're
it.
doing like
Yeah, that's it.
Okay.
you didn't have the square bracket there
Where? Here?
in the one? Yeah.
On the 1, no, because we exclude 0. We exclude 0 here. Why? Because it never touches this axis.
Oh.
And because we're never hitting 0 here, we never hit 1.
Okay.
Is that fair? Okay. So I do it step by step. You can do it however you like, okay? Not however you like, obviously, but... Okay? All right. Okay. Is that all right? Again, if you desperately need another way to do this, I'll cook something up. Okay, we've got... How much did I do? The range? Okay, so the range... The range is everything above 1, and that's also the domain of the inverse. Okay, and now we find the inverse. Now we find the inverse. Y equals e to the x. Okay? You can take ln of both sides, or write this by inspection. You guys okay with that? Am I okay with that? Yes? Okay? Questions? Okay? Take ln of both sides again. Ln of y. Okay, so f inverse, no, not f, g. Inverse of y is ln of y. Okay, or you can put x in there. Okay, or a picture of a cat. Okay? Yes, sir?
It's H.
Anywhere else?
Don't be this harsh on us.
What's that? Oh, the only person I'm harsh on is me, don't worry about it. Look at how, this is unbelievably unacceptable. I've written F here, imagine that. Okay. Alright? Picture? Here's a question, could I be going more slowly? Okay. Hey, look at that. They're inverses. And we don't have to restrict anything this time, right? Everything's implicit in here, okay? For this to work, you have to have this happen, okay? Because if you feed in anything less than 1, okay, either this thing's going to fail anyway, because if you feed in anything that's 0 or less, this guy's going to be upset. But also if you feed anything less than 1, even if you get something out of here, it'll be negative, and so this guy will be upset. Okay? So that domain works implicitly. You don't have to add anything. Okay? Questions? I could do B or I could do something else. What's something else? Something else is sketching transformations and doing log and exponential problems. Because we haven't been doing that so far. Who wants B? B or not B? Okay. That's almost a quote. All right. Just to be a maverick, I'll use orange. Okay. B. Okay, you want the domain of G. Okay. Okay. What can we stick in there? Yes, ma'am.
Anything other than 0?
Perfect, good. Okay, if I stick in 0, this guy gets upset. This guy doesn't care what you give it, and that's it. Okay, so the only thing you can't put in is 0. Is that fair? Don't divide by 0. Okay? Don't divide by 0. And this is our silly way of saying that. And this is also the range of the inverse. Okay, everything but 0. Fair? Okay. All right. Range sign. Okay. What does 1 over x spit out? Good, and it gives out the same thing, right? It gives out everything but 0, right? Exactly. So the graph of 1 over x is that, right? And it spits out everything other than 0, okay? On that, on the same domain, right? On that domain, if you don't give it 0, it'll give you everything but 0. BB-8 impressions. I don't know if anyone asked me. Okay. Okay, so when I stick the domain in there, 1 over each bit of that is going to return, again, everything but 0. Okay, this is absurdly cumbersome notation. Do you understand what I'm saying? Okay, 1 over x returns everything that's not 0. Okay? When you give it anything that's not 0. Okay. Okay, then what do? We go e to the that, e to the that, e to the anything but 0. All right, what does that give me?
Y is greater than 0.
Y is greater than 0 and what else? Okay, so if I feed this anything but 0, okay? So already it's got to be positive, and I don't give it 0, so not that either. Does that make sense? So I give it anything other than 0, I'll get everything positive except for 1. Okay? Okay, again, this guy spat out anything but 0. Okay? Exponentiating gives you positives, okay? Expands the positives. But if you're missing 0, then the exponential will miss 1. And that's all I'm saying there. I'm saying anything positive other than 1. Okay? Again, write this out in a way that makes sense to you. If you have a question, raise it, because otherwise I just hear noises. And they might be in my head. Okay. Okay, if I add 1 to... If I add 1 to a positive number that isn't 1, I get a number that is greater than 1 but isn't 2. Okay? Does that make sense? Or you could have just drawn a shifted version of this and gone from here to here. Okay? And what would that have looked like? It would have looked like this. It would have looked like this. So if I combine these two steps, I get something that looks like that. That's 2. Okay? And I'm saying if I feed anything other than 0 in here, I get anything greater than 1 other than 2. Anything greater than 1 other than 2. Okay? Ish? Draw pictures. Think in a way that makes sense to you. You don't have to use my weird notation like this. Okay, and what's this? This is the range. Or the domain of the inverse. Again, I like thinking in pictures. I like thinking step by step. If you've got another way that works, that's fine, okay? Like the way we talked about for the first problem. There was a sort of shorter way. If you can just think through it that way, that's cool too. Okay, finally, let's write out the inverse. And I don't need you anymore. Yes, I do, because I can't remember what I'm doing. E to the 1 over x plus 1. Solve for x. Y minus 1 is equal to e raised to the 1 over x. Take ln of both sides. And solve for x. And that's our baby. And I did it again, didn't I? G. No. Oh, it was this one. Okay. There you go. Red guy and black guy are inverses. Okay? There you go. And again, you don't need to explicitly specify this domain because it's sort of built into this guy. This guy gets upset if you do anything other than that. Okay? If you give it anything less than 1, this ln will get something negative or, non-positive, and it'll be upset. And if you feed in 2, you'll get 2 minus 1, 1. Ln of 1 is 0, and you'll be dividing by 0, and that's upsetting. Okay? So you could have just figured out this domain by looking at this. Okay? Okay, but sometimes you get misled, like in that first one. Are we cool? Okay. Okay. Right. Who wants a transformation example? Wow, that's good. Come on.
It's okay, you don't have to do it.
It's either transformations or inequalities or please don't say inequalities or logs and exponentials. I'll do another one and then and then we'll maybe come back to those of you who I'm disenfranchising. I did a bunch. Okay, I'll do an annoying problem first because I love it. It says, tell them if they want any problems for fun challenge, I'll supply. Okay, I wrote that myself. I have a bunch of problems from problems books and contest things and all those kinds of things. If you want something challenging or fun or whatever, just let me know and I'll give you a bunch of those, all right? If this is all boring you out of your minds, okay? All right. And I stole many of these from those kinds of contesty things. But they're not hard questions. Here we go. From the 1998 Euclid question 3, solve log base 5 of x minus 2 plus log base 5 of x minus 6 is equal to 1. Okay? Again, I'm begging you, if you see a sum of logs, don't write that as a log of the sum, okay? Don't do that. All right, what do I do here?
Log 5x minus 2 over x minus 6.
Over or
Wait,
something?
no.
Multiply is good, okay? Good. If there are any objections at any point, tell me. X minus 2, x minus 6. Is that fair? We saw that rule? Okay. But, yeah. Okay, what's next? Oh, so log 5, what does that mean? I'm sure you're right. Say it again, one last time. Oh, perfect. Yeah, that's fine. Okay, yeah. This is log base 5 of 5? That's perfect. Yeah, good. Or just go 5 to the this, 5 to the this, and that works too? Yeah? Or go you love that course. Or go, if this is the exponent and 5 is the base, then all of this bit is 5 to the 1. Does that make sense? So some way or other, get to this. Okay, that was the base, this is the exponent, da-da. Good? All right. Hey, what's 5 to the 1? You told me already anyway, yeah. Okay, here we go. X squared minus 8x plus 12. Right? Okay? Subtract 5 from both sides. All right, what does that do? Who has a solution? Or both?
X minus 7, X minus 1.
Perfect, thank you. X minus 7, X minus 1. Okay, so X equals 1 or X equals 7, yeah? Okay? Is that fair? Any objections? But what can't I do? You can't give these guys non-positive, right? All right, so x minus 2 was supposed to be positive, and x minus 6 was supposed to be positive. So that's just the same as x was supposed to be greater than 2, and x was supposed to be greater than 6. Or in other words, x had to be greater than 6. Right? And yet we claim this thing is a solution. Okay, this is inadmissible. This is no good. Okay, the only solution is x equals 7. Okay, you can't give a log something that's not positive. Okay? And you go, well, why did that happen? Well, a few things. One, the rule we talked about was only for positive things in here. Okay, and yet we didn't write any of this stuff, and we should have. Okay, so we should have noted these restrictions and then gone on. That's point one. Point two. When you bring these guys together like this, it's possible for them both to be minus, and then for the product to be plus, and for this to all look fine. Okay? And that's kind of what happened here. Okay? So you hid the fact that they were both negative by multiplying them together and getting a positive. Okay? So don't forget this stuff. Okay? Only the 7 was good. Okay? So check that your solutions make sense. All right? Yes, ma'am. Okay, so I said log base 5 of thing is 1. Right? So the exponent to which 5 must be raised to get thing is 1. Is that it? Is that okay? Or you go 5 to the each side of this, if that makes you happy. Thank you. Good? All right. Okay, here's another one. (1983) Euclid, problem 2a. No. Problems and how to solve them, volume 2. You see, that's academic integrity, guys. You copy people's work, but then you claim you give them credit for it. Hey, you know what? Let's make that a next. Okay, solve me. No tricks this time. All right, what do we do first? Hint, whatever you did here, you can do it there. Okay? However you figured this step out, you can do the same thing here. Okay? 9 sounds good to me. Great, okay, exactly. The exponent to which I have to raise 3 to get thing is 2. So thing is equal to 3 to the 2. Okay? Or whatever other way you like doing it. You go 3 to the both sides, do what that gentleman said, whatever you want. Okay? All right, what's next? Good. Do it again and bring the 3 both word. Okay? Good. So one thing you can do is bring the 3 out. So when you've got an exponent inside a log, you can plop it out. Go 3 log base 4 of x equals 3 squared. Okay? And then you wind up with 3 is log base 4 of x. Yeah? So what's x? 4 to the 3? Please. Yes, that's good. Okay? Okay, good. That's one way. The other way is, yeah, do the same thing we did before. So go x cubed is equal to, and that's just 9. Okay, x cubed is equal to 4 raised to 9. Okay, you can take cube roots of both sides and just wind up with 4 to the 3, 64 again. Okay? Okay, these sorts of steps, do them however you feel happiest, okay? Go 3 to the each side, just look at what the log means. Okay? Questions? Okay. This one's probably both familiar and uninteresting. Simplify. Root A, B, over cube root AB. Someone want to suggest something? Oh.
So you read it as bracket A, bracket B, 1/2, bracket, and then bracket all of it to 1/2.
Brilliant, that's it, good. Okay, good. Yeah, so great, write it as powers. Okay, AB 1/2, all to the 1/2, over AB 1/3. Wonderful. Okay, great. And you can bring the exponents in? Oh, okay, good. Go A to the 1/2. All right, however you want to say this. B to the 1/2, 1/2. You can do some of this in your head. A 1/3, B 1/3. Okay, this is just B to the 1/2 times 1/2, so it's just B to the 1/4. How low am I? Okay, A to the 1/2, B to the 1/4. A to the 1/3, B to the 1/3. Okay. 1/2 minus 1/3 is 1/6. One quarter minus 1/3 is minus 1/12. And that counts as simplified. Okay? Is that cool?
Wait, don't you just don't you
Hmm?
You have to put it back into the same form you got the question. Like you got the question with roots, you have to put it back in that form.
I'll say that one more time with.
Like, you know how you wrote your final answers for fractions? You have to put it
Uh,
back in the same form you got the
Oh, with roots? Yeah, you could do, yeah, I guess.
question.
Whatever you want. They're both right. As long as you're right, you should be all right. Yeah, just don't leave it like this and call that simplified, but yeah. So what'd you write? You write like 6th root of A over 12th root of B, something like that? Yeah, that's cool. Okie dokie. Okay, here's an ugly one. Canadian Senior Math Challenger Contest 2015, problem 4. I'll do this or a transformation. What's a transformation instead? How is it that the people change? It makes sense for the numbers to not change. But the people should. I don't get you folks. Solve 4x. Here we go. 2 times 4 to the x squared minus 3x squared. This problem is just might as well just be called opportunities to screw up. Okay? Who's got an idea of what to do here? You can talk, although I kind of promised in my head to go back to you because
Okay, so like 2 and 4, you can all write them as like 2 to the exponent or something, so you can change it to like log base 2. Does that make sense?
Would you do something to this?
Yeah.
Say it one more time.
Can you just put it log base 2 of like 2 to the x and then bring that in?
So log everything?
Yeah.
Yeah, but you could. And then this 2 would come down? Uh-huh. Yeah, you could do that. You could do that. Let me do another way, but yes, you could do that. You said something, and then, oh, look. Yes, because I've spoken. I like that. Yeah, that's cool. Is that, yeah? Okay, that's pretty cool. All right, write everything as powers of 2, and then you can equate the both sides. Okay, and why would you do that? Well, 4 is suspiciously a power of 2, so why not? Thank you. And your way works perfectly well. Okay, so 4 is just 2 squared. Okay. I'll do this in an unnecessarily large number of steps. Okay? 2 to the a all to the b is 2 to the ab. So just multiply this stuff. 2x squared minus 6x all squared is equal to 2x minus 1. 2 to the x minus 1. Okay. 2 times 2 to the something is the same as 2 to the something plus 1. Good? 2 to the something plus 1, all squared. Okay. 2 to the something squared, 2 to the something all squared is the same as 2 to the 2 times something. So that 2 becomes a 4, that 6 becomes a 12, that 1 becomes a 2. 2 to the x minus 1. Hey, goody goody. Okay, what do we do? This guy's equal to this guy? Yeah? Okay, right? Yeah. So in your head you're definitely going, yeah, it's because they're 1 to 1. And then you can take log base 2 of both sides, something like that. Whatever you want. Whatever happens in your head, afterward you get this. Okay? Okay. That's the full word. Good? Make it look like something we can do. Who wants to factor that? Ooh, yep. Oh, also late. You, yeah, go ahead.
Okay, 4x minus 3 and x minus 1.
Does that work? Does that work, or is it the other way around? I say 4x minus 1.
Oh
Yeah.
yeah, sorry, 4x minus 1 and then x minus 3.
Cool, excellent. 4x minus 1, x minus 3 is perfect.
Wouldn't you, like, 3x instead?
1 sec. Is that what? Okay, what?
Like, when you take the x over, would it not be 3x squared?
No, because that was 4x squared, and that's just an x, so it matches with this guy.
On the next, oh, okay.
Is that right? Yeah? This guy gets subtracted from both sides to do this.
Oh, yeah.
Cool? All right, 4x minus 1, x minus 3 equals 0. Cool, great, excellent. So x is equal to 1/4 or 3. And you can look through this and see that there's nothing wrong with that. Okay, nobody gets upset. Okay? Okay. Yes, and I think like you said again, if you just took log base 2 of both sides right at the start, you could have gotten somewhere in pieces, I think. Okay, questions? Okay. I'll give you choices, and then you can pick one of these, and then I'll do transformation. You said ambitiously. Okay, here are your choices. A, log base 2 of 3x plus 4 minus log base 2 of x minus 3 is equal to 3. Solve. E to the minus x over 2 times square root of 3e to the 2x minus 8 equals e to the x over 2. C. Hey, you know it's going to be 4 choices. 7 to the x plus 2 minus 7 to the x is equal to 48 root 7. Or this weird thing. E to the x plus 1 equals 6 e to the minus x. All right. I think you don't tend to get asked stuff like D, but it's cool. And I remember it from high school as well. Okay, guys. A. B. C. D. Well, I'm in B. Yeah, B, huh? All right. Thanks, guys. All right. Good one is both ugly and boring. Here we go, B. Again, if you want stuff that's cool, when I say cool, fun, brilliant, ask me. E to the minus x half, square root of 3e to the 2x, possibly, minus 8, equals e to the x over 2. All right, what seems like a good idea? It's similar-ish to what seemed like a good idea last time. Sort of. What do you want to do? Okay.
Oh, okay.
Yes.
Change it.
Change it to
Power of half.
power of half.
Multiply
Multiply. Yes, multiply by what?
by what's inside the square root.
Oh, by what's inside the square root. Good God. But multiply everything by this? No.
Okay, so you know how there's a square root, you can change it to the power.
Oh, this thing. No, not the. Oh, it's right. This is this to the 1/2. Yeah.
Yeah.
Okay. What do you do then? You can't bring it in, right? Because there's a difference in there rather than a product, right?
Yeah.
Yeah. What's up?
You should divide both sides by the e, and then combine their exponents with the exponent amount.
I like that. This guy. Do something with this.
Yeah, divide it out.
Yes. Perfect. Really. Okay. Good. Yeah. Do you want to say something? You didn't want to say something. Okay. I can't tell if this is a hand raiser or anyway. I get confused. Right, brilliant. So divide everything by this guy, right? Or multiply everything by e to the x over 2. Okay, so if you multiply both sides by e to the x over 2, you get e to the x over 2 times e to the x over 2 over here. Okay? So e to the x over 2 plus x over 2, so just x. Okay? And this guy gets canceled out. So you get given this. Yep. Okay. Now what? What's the natural thing to do now?
Log.
Square works. Is that what you, yes? No? You said log. Someone said log. Log?
Yeah, so log it first, but-
Log. See, then you get like, yeah, you get something weird, wouldn't you? Yeah, okay. Okay, good. If you square both sides, you wind up with this. that cool? Do you square both sides? And at first glance, doesn't seem like it's going to do anything terribly upsetting because this guy's going to wind up being non-negative. It should work. Okay, so we squared both sides. We had equations that looked like this. The square root of stuff is equal to something, let's call it z. Okay? Now we've got something like this. Not only does this stuff have to be non-negative, but the stuff that the square root spits out also has to be non-negative. So z has to be non-negative. Okay, so it constrains z non-negative. But to solve stuff like this, often we square both sides to clear the square root, and we wind up with something like stuff is equal to z squared. Okay? When we do something like that, this restriction disappears. So we've either got to remember it or write it down, otherwise we won't see it anymore and we might get tricked. Okay? Squaring isn't a one-to-one thing to do. So you might lose information and come up with solutions that aren't real. Okay? So whenever you square, be a bit cautious and think that you might have introduced some false solutions. Okay? And check that your solutions actually make sense. Okay? And when you've got restrictions like this, and you might be losing them like this, keep them in mind and check them later. Okay, and this came up twice. Once it came up, and we solved it by saying that we needed to explicitly restrict the domain. And once it came up, and it happened that z was equal to e to the x, and that forced it to be positive anyway. Okay? If that doesn't make sense, just come ask me after. Basically, the lesson is when you square, be a bit nervous. Okay? Then what? Yeah.
Are we allowed to move the e to the power 2x over 2?
Over?
Yeah, because...
Over this?
Yeah.
Yeah, but then you have to divide this guy by that too. You have to divide everything, right? Right, and this guy's kind of ugly. Yeah, I'm sure you could. Yeah, you could, and it would work. It's just more steps than you need. You could do that, yeah. So divide, but make sure you divide all three by that, yeah? Yeah, that works. Okay, or I just do the, bring this guy over. Yeah? Cool, and then what?
Log both sides?
Log both sides is cool. If you log both sides, you get 2x equals ln 4. Okay, so x is equal to, I don't know how low I am, ln 4 over 2. Okay, and that's how I left it until I realized I was being silly. What's that? X equals to ln 2. Okay, because ln 4 is ln 2 squared. That 2 comes down, 2 ln 2 over 2. Cancel, cancel, ln 2. Okay, and you can check that that's valid. Okay? All right? What I saw someone did, you could do this. You could. I saw a solution that said something like this. Let z equal e to the x. Okay, and then you throw that in here, so that becomes z squared, and then you play around. And then once you get here, you're going to see something like z squared equals 4, and then you get z equals plus minus 2. Okay, and then you go, ooh, but an exponential can't be negative, so it must just be 2. Okay, and then you work from it. Okay? But I like this. Are we good? 1, 2. Is there another one that's, maybe I'll do transformation. I'll do one transformation, and then we'll see. All right, what would you like me to play with? A straight line, a quadratic, a hyperbola, an exponential, a square root, a log, or put absolute values in places. Ooh, hello. Yep.
Oh, actually, maybe you could just put the answers beside A.
These guys? Yeah, I could, couldn't I? That's assuming I know them. I know a few of them, and one I have to solve. Yes, give me a second and I'll write it until I forget. Let me get this vote then. What functions do you want? Someone shout something. Amazing. The one I didn't work out. Just amazing. All right. I did like 12 and this is, yeah, anyway. Good. You guys are fun. All right, let's sketch y equals, what do we want? Log base 3 of 2x minus 4 squared minus all that. And stick a 1 up here. Okay, I'll do that one. And it's the only thing I'll have to actually check. Brilliant. Okay, good. Okay? Is it doable, first of all? Yes? Okay. All right, should I just do this, or do you want to say something? All right. Okay, cool. So, I'll get this in the form that I like, okay? And the form that I like I said, is something like this. Something that looks like this. Because that's what I was taught to do. Okay? Okay, and in this case, f, in this case that f at x, that core thing, is log base 3 of x. Okay? So let's play with this. I could write this as minus, bring the 2 down in front of the log, and factor this guy, and add the 1 on the end, over here. Okay? All right. So, I'll do it here. Can I erase this? I hear a scream on. All right. So here we go. Man, the regret of this. Here we go.
Non, je ne regrette rien.
So, what does log base 3 of x look like? Okay, it goes like this, goes through 1, and then at 3 it equals 1, so at 3 it equals 1. Put that point on there, and pretend that that's good enough. Okay? All right. Okay, so that's our core function, and what do we need to do? I need to flip it vertically, I need to stretch it vertically by a factor of 2, and I need to compress it horizontally by a factor of 2. Okay? All right. So again, flip vertically because of that minus, stretch vertically by 2, stretch vertically by 2, and compress horizontally, thanks to that 2, by a factor of 2. Compress horizontally by a factor of 2. Brilliant. Okay. So flip vertically. That was satisfying. And then stretch vertically by a factor of 2. So that guy stays where it is, right? Flip vertically, stretch vertically by a factor of 2. That ain't gonna move. Compress horizontally by a factor of 2, so that moves to the 1/2. Okay? Colors. Okay, so that point goes here. To give blue. Okay, does that make sense? That the 1 goes there? Okay, flip it, vertical stretch does nothing, and compress it horizontally by a factor of 2 to get that to a 1/2. This guy, flip it, it goes down here. Stretch it vertically by a factor of 2, so it goes to -2. Compress horizontally by a factor of 2, so it goes to 3/2 and -2. So -2, 3/2. Okay, once again, it's this point I'm talking about. Stretch it vertically. Okay, so flip it first vertically to get here. Stretch it vertically by a factor of 2 to wind up here. Compress horizontally by a factor of 2 to wind up here. Okay? We had an asymptote here. We can look at that as well. Flip vertically does nothing. Stretch vertically does nothing. Compress horizontally does nothing. It's where it was before. Okay, so this is what it's going to look like. Ish. Okay? Okay, almost there. Shift right 2, up 1. Good? Aight. Shift right 2 and up 1. Don't forget minus means go right. And don't forget how screwy this thing can be as well. Okay. To give red. Okay, right 2, up 1. Oh god. Okay. Right 2, 1/2 goes to 2.5 over there somewhere, and up 1. So there. Okay, so it's 2.5 and up 1. Okay? Did I do this right? Right 2, up 1. Okay. Here's my other reference point at 3/2. So 1.5. 1.5 plus 2 is 3.5. So over here. Ish. It's fantastically poor scaling. Okay? So shift this guy right 2 to 3.5. And up 1 to minus 1. Okay, our asymptote shifts right 2 from here to 2. Boo worms. Let's say that's 2. Shift right 2 and up 1. You can shift the vertical line up as much as you want, nothing's going to change. Okay? So there we go, that's it. There's our asymptote, there's our final curve. That's it, that red guy is your final answer. Did that make some sense? I was in my own little world for a long time there. Yeah.
So like, when you say vertically, affects the y values, right?
You know, like a really innocent person, I'm going to unplug the video now as I go on the internet. Yes, ma'am, go ahead.
So like, when you're given like a list of values and like it helps you like transform the function, like when it says like flip vertically, you affect like the y value.
When you flip vertically, affect the y value, yeah.
You apply, and anything that's vertically is just you apply that factor to the y values.
Yeah, so whenever I say vertically, it's always the y values. Yeah, that's right. Yeah. And we're back. All right, let's see here. 1 minus. Well, come on. You're all leaving, aren't you? Let me see if I want to say anything before you go. She wanted the answers to this. I'll give you those answers. Just come to me. Yeah, if anything else, just ask me. Otherwise, I'm just going to be checking this thing. If you feel ripped off and I haven't addressed something you care about, let me know that too. Otherwise, have a very pleasant evening.